Hi guys, welcome to another code film. This code film is a payload encryption code film, but this is the episode on money transfer. In this episode we are going to look at how we do payload encryption and what happens when we don't do payload encryption, or what could happen when we don't do payload encryption. It's an application security concern because we could be handling sensitive data, or we just could do it just to make our application secure. There are takeaways that I want us to look at: the OSI models, asymmetric and symmetric encryption. AES is symmetric encryption, RSA is asymmetric. If you haven't watched the fundamentals video, please do so. The link is just right in the description video. So let's just get started. Money transfer. So let's go to our services, Eclipse, and then this will be the application that's going to help us to do money transfer. So first of all, we have the portal and we have the API or web service. So we start our portal so we can all see the interface that is going to help us send money from one person to another person. I must say that there's a lot of technical stuff working behind the scenes and terms, and that's all not the focus for this code film. So all that have been abstracted out, focus just on the payload encryption money transfer scenario, so you understand why or how to do payload encryption. So the portal has started, is on port 8082, and then the context part is transfer money transfer portal, and it's happening on localhost, so it's on a machine. It's on this device. This particular device is not on another server or anywhere known. So I'm going to use a browser to access that. So I'll go to Google Chrome, open an incognito window, and just go straight to our browser. So HTTP, don't worry about that, localhost, and then the path to our interface to send money is a show. That's the path. If you can't remember, you can easily find out from the portal controller. Instead, this is the show. It goes to the show window. Sorry, I built it from another service. Go to the show money transfer view. Yeah. So let's just go straight there and see what we have there. So this is our portal. So you enter the person's number, the receiver number. You enter the sender's mobile number, that's your number. Enter amount and enter transfer. It's for understanding sake, so just understand this, okay? Don't argue with it, just understand. So I'll send them. I'll enter for now. Our portal is up. But our API is not up. So let's start our API. How do I know? Let's just do a demo and put any number there. Let's just enter an amount for you transfer. Okay, so it crashes. It says I can't connect to a certain, so our portal is not, our API is not up. So let's just go back. Let's start our other service or other API. That's the money transfer service. Start that service. So it has started. Someone asked me, how do I know if a service is up or not? You can curl or you can telnet. Curl to the URL, telnet to the server and the port. So this one is up now. So you can see it's up. So let's reload it again. So yeah, you can curl or you can telnet. Oh Lord. Let me go to Git bash right now. Let's just do this. Sorry, I want PowerPoint. Git bash, yeah, Git bash. I'll use Git bash for this. Git bash. The reason I'm using Git bash because I want the Linux or the Unix feature. If not, I could have also used mobile xtem. So let's see if I have mobile xtem to my machine. I also have mobile xtem, so let's open mobile xtem. Mobile xtem 2 is another Linux environment kind of software, so it gives you the Linux features, yeah, and you use it a lot too in industry. It's all Linux, just gives you the Linux environment, yeah. Let's just close this. Let me just stop everything. Okay, so clear. Alright, so this is mobile extend for you, so it gives you that Linux environment you want. Someone say, how do I use a Linux? You can do an ls. It shows you the files on my desktop right now. Alright, so let's do it clear. That's the same thing I was going to do with git bash. So I said you can, how do you test the services app? You can telnet, or you can kill. So if I do a telnet and then I enter the local host and I enter the port 8443, it says connected, that means it's available. Let's go back and let's offer our service. That's we are stopping the service. So that's for the money transfer. That's the API. It says that it was on port 8443 and then it's running on localhost. It's not on another server. I haven't deployed it to another server on another network. No, it's all on localhost. So if I do another tel now, it says it has stopped. It says trying, unable to connect to remote, connection refused. The reason I'm using mobile extend is that the telnet program comes inbuilt with Linux, but when I go to Windows, let's go to CMD and let's try to enter telnet. If I haven't set telnet up, it won't work. You understand? So telnet is up, but in most of the cases in Windows machines you have to how do I leave this? You have to have telnet configured for you, because telnet is an application that Windows will not let you just have access to. It's a configuration. So how do I, let's just confirm telnet. So you have to turn Windows features on. Let's just go there, open. So you see telnet is up, but if telnet is not up and I close it, you realize I need to go through that same to give us a challenge. This is not my focus, but it's a side thing, but because it's a little bit technically loaded, I'm just adding everything into one video, not what to take us off track, just staying focused on the payload encryption. So telnet is not something, just for you to know that this is how you test your application is up. And then it's all the OSI model, application layer. These are commands to test that you can, a service is up or not. So that's just one. It's keeping long. But at least you see that I was selected, so I think we are fine. Okay, applying changes. A bit of patience, then we'll be fine. So that's for you to know. So let's start the service again. Now you know how to confirm if a service is up or not. So if your networking is a bit strong, you realize that just by typing the command you get the idea. But if this is your first time knowing telnet and kills, you realize that it looks weird. So telnet to that server and that particular application, the application is sitting on 8443. So that's why we use a telnet. So if I telnet again, it says connected, meaning the application is up. When it wasn't up, it says that it couldn't reach it on my local machine. So my local machine, like my personal network here, that's my network card. Yeah. Okay. Yeah, this is my computer, my personal computer. Alright, so we're fine now. Now we know how our service is up or not. And if we go back to the Windows command and then we try to enter, is it still trying to apply the changes? Well, it's still trying to apply the change, but you saw that we have to select telnet. So whenever it's done, we'll look at that, but that's not our focus. So our service is up. So we enter our destination, that's MTN Tigo, and the sender is MTN. Then we enter the amount. It's a little, for you, it's a little bit huge. is a lot of money. So transfer, voila. So our message says that your money transfer of 100 to this number with the reference for you has successfully been completed, and we have our transaction ID. So this is the scenario. Now let's get straight into the application security. Now if you're on a public Wi-Fi and you are sending money, you have this access to this portal. Let's refresh, let's go back. You have access to this portal and you are sending money on a public Wi-Fi. You are doing yourself a lot of disservice, because when you're on a public Wi-Fi, we'll look at the OSI model very soon, and we'll look at the relation. Your data, if there's no payload encryption, your data is going to be tampered with. In other words, hackers or bad persons or criminals can have access to information they're not supposed to have access to. How is this possible? Let's now get into it. Okay, we've started. Please stay with me. The API service we are looking at. Let me put the OSI model now. OSI. Let's put this up now. And let's look at this diagram to understand what we are doing. So remember, these are the highlights we made mention of. So the API that you're working with, sorry about it, that is not coming out well, but it's good for me. It's very, very good. So this is your application layer. This is the application. This is the TCP/IP model, and this is the OSI model. There are two separate models. One is a summary of everything. One is the actual breakdown of everything. So you're on the application layer. That's where that's where data is. And then you're on the network. This is the physical layer. This is the network access layer. And then you're sending money from one mobile device to another mobile device on a network. Because you're on a network, your data, you can listen to the data on the network. It's networking. Remember from the beginning that this is all physical, connecting to computers, cables. It's all physical. Then you have the IPs being distributed due to DHCP, IP routing. Everything is taking place. Then you have the transport, TCP, UDP, all taking place. That's helped to find the right packet and the source and destination IPs. Then you have sessions controlling the communication between two different applications, and the final presentation for you. All this, there's a tool that can help you to see everything that's happening, and it's networking. There's a tool. One is WireShark. You can also use TCP dump, and the reason is that it's computer, it's programming. Once you can look at you can have access to the drivers that are showing, that are helping you to do all this, or you can have access to, you can write code that can listen to different ports. There are libraries that helps you do that. You can build an application that can help you to analyze everything. Just the same way you are building an application to send money. You understand? You have the understanding. So someone who has the understanding and has built a software that can help you to listen to everything that's happening on the network. So we are going to use that software called WireShark to analyze our network or listen to our network. If you don't believe, there's someone sat down and built it. You too, you can do the same. It's understanding of the networking principles. If you also want to check how electricity is flowing through your building, you can use an ammeter to do that, or a multimeter to do that. As simple as that, because there are principles. So now let's start using WireShark. So I'm going to start WireShark now, and I've explained why I'm using WireShark with the OSI model. It should make sense. If not, you can ask questions in the comment section. So WireShark is a tool that is going to help us to listen to our network, or listen to, they call it packets or data that's moving in our network. So you can actually see the name packets. So you want to see how the data is flowing. So because WireShark is a network analyzer, you can capture from different interfaces, and that comes down to the physical layer here. So that's the network access. So I can listen on my local area network on any of them. I can listen on a Wi-Fi. That's WireShark, the tool is going to listen on the public Wi-Fi, or I can listen on Ethernet too. I can also listen on my loopback traffic, because the IP address 127.0.0.1 is a loopback. You can say there's traffic on it, but because I'm not connected to any local area connection, I don't have any Ethernet, you can see that there is no traffic on it, or there's no data on it, or packet on it. By the Wi-Fi there's packet, because I'm on my Wi-Fi. If I want to see the data that is being captured, looking at this network layer, looking at this WireShark model, the software is able to see how data is being moved from this physical layer. That's where we are doing the connection. That's our Wi-Fi all the way to the top. It's possible. It's just possible. That's why we are using WireShark. So we are going to capture it on our loopback traffic. That's here. So we are going to start entering the payload encryption. So you see, I'm going to capture all data that is flowing on my loopback. I've clicked on it. That's the network device, and I'm going to start sending requests to my API using a portal. So let's go back to our portal now, and let's start sending data. You know, the portal is the application, and it's on the application layer. You get it? So the OSI model is all working. It's a stack. It's all that concept is all flowing right now. You understand? It's all flowing. Data going up, data coming down. It's all flowing inside, just like that, in the twinkle of an eye. So you can see that one way or another it's starting to read something. We haven't yet sent any request, but it's listening. You know, source and destination, source IP, destination IP, source IP, destination IP protocol. Where are we on the stack? Source and destination, and the time. So okay, so let's go now. So let's start. Let's fire. We have our mobile number. We are sending to Airtel Tigo. We are sending it to MTN. Enter the amount, and then let's enter for you. Let's see the transfer. So let's see where we are right now. It's somewhere here. Let's see if it will capture it. So this is our source. Our source is 127 because it's our personal machine. Is this my laptop that I'm using to do the communication? It's on every computer. Like every computer has a loopback or local host. Yeah, just staying on your local machine. So if I hit transfer right now, good. It's starting to capture something. Look at it. So let's start. Let's filter. So we want to capture what we want to see, what has transferred in the network. So we'll do TCP contains. We are searching. Let's search by the port 8443. Did this show anything for us? Let's see. It's not producing any results. Let's go back. Let's do this. TCP contains. I'm sending from one IP, so I want to find a keyword that will help me to search for. But I was already showing the HTTP side, so let's do TCP contains. Let's do HTTP. Okay, so HTTP is showing something. That's one. Okay, maybe we don't like this, so we can do TCP contains. Let's go back. How to search? You can easily Google how to search, like what you are searching for. You can easily search for it. So this, what you are using to search, you know, on the network layer, you have HTTP. On the application layer, we have HTTP, we have the port 8082, we have the money transfer. So the application we are sitting on is what we can listen to. We can listen to TCP contains 8443. I don't think that will work because it's on. That's not what we are capturing. So what we are capturing, unless there's a way of filtering better, but as it stands now, I haven't come across that. So TCP contains, I'm going to find 8082. It's also not pulling anything from the port side, so let's do TCP contains HTTP. That one helps us because that's the protocol. So if not, then we just type HTTP. Let's see if HTTP also pulls something. So you can even ignore the TCP contains. Let's do just HTTP. And if you're not satisfied, do HTTPS. If not still pulling anything for HTTPS, then use SSL or TSL. In other words, search based on what was shown to you. So if you had fired this again, let's fire this again, and let's see what will come. Let's change the amount. Let's change it to 200. It tells where is the protocol, where it is located. So we're at the bottom now. So once we send it again, you see it starts showing us what we want. Okay, so we can just filter or set by HTTP. This is not a WireShark class, so just accept. Okay, alright, fine. So now let's go down and let's understand the packet we have received. So remember we explained that the OSI model, let's just go. I don't want this video to be long, but it's becoming long. So remember that the OSI model sends data in this form: application, presentation, session, transport, network, data link, physical layer. That's the breakdown WireShark has given to you. So this is the HTTP. It helps us to see what we are doing. So this is what the URL we are accessing, and then this is the service. So this is the portal for you. So on the portal, you can see that you can actually see. Click on another packet, post. You can actually see what you are posting. You understand? So if you click on request, full request, it comes HTML form. Right, so where is this one actually? Copied. Alright, so you can see that our request here, but it also presents it to you here, the XML form. So this is the data we are sending. It's actually the same thing. And the response, that's the response here. Right, so we can listen. So you can see this is our request we are sending. So let's hypertext protocol. This is the form. This is what we are sending. Alright, so everything is being shown to you in plain text because it's not the actual API sending the service, but it's just the portal. You don't see how you are prone to vulnerabilities or you are prone to why we need a payload encryption. So now I'm going to swing to the API side and I'm going to fire the API side. But do you see? You can see that when you don't use, when it's on HTTP, nothing is encrypted for you. Everything is showing raw. You get it? But the good thing is that you can't see the URL that is being sent to. You just see the source. You don't even see which URL is doing that behind the scene, unless you can do inspection. Let's try and see something. Let's inspect with the browser and let's see if the browser will expose that URL for us too. Okay, so let's go straight down. MoneyTransfer portal. Alright, so this one too doesn't show you anything. So we have kind of secure here because on our portal side we don't see the URL that we are sending, the web service that handles the money that we are sending to. That's very good. But you do see on the HTTP side that the form data values is all showing. It's not encrypted. Like there's no encryption because it's on HTTPS. So that's the downside of it. So sometimes to do not payload encryption, but to keep your application secure, you install certificates on the server or you put it in the application too. So you can make your application secure by exposing it on HTTPS, or you can also install certificates on the server. A whole lot of stuff. Okay, so we are fine now. At least we get the understanding. We see something we've inspected, but thanks be to the developer, he didn't expose the endpoint that is sending the money to, because he kept it in the application file. He kept it in the properties file. So because it's kept in the properties file, that's here. We are the only ones that can change it. It's not in the code. If we were to be in the code somewhere, by me being careless, trust me, there will be a way of exposing tampering with data, but you don't even see the API that you are calling. Okay, so now let's go straight to the API side. So you can be lazy. You can be lazy in the very fact that you can use HTTPS here, and you use HTTP on the actual web service. Nobody will know, like, because it will be secure on HTTPS. It will work, but you won't see. But to be sure that your application is secure end to end, when you encrypt or install on HTTPS here, as you do HTTPS, you install a certificate for it to handle end to end encryption. There's a video that I'll prepare for that. Just put that in your brain. You won't be able. You are not supposed to be able to see the values that you are even sending. Everything is supposed to be secure, because you are not supposed to. It's supposed to be end to end encryption. You are not supposed to have access to see sensitive data. When we get to the API testing, we see that. So now we're fine with this. This is the portal side. So you send the money and we've had access. So we don't see the URL that we are sending the money to. Okay. Now let's go to the API side. For that, I'm going to use a different agent. That's Postman. So I'll go to Postman. Okay, and I'll clear all this. I was testing something, trying to bring more clarity to what we are doing. So this is Postman. So we have HTTP and we have HTTPS. HTTP is not encrypted. Everything is in raw text because that's the default. But HTTPS, everything is encrypted because you install a certificate on it. So the first part was just a scenario. Just everything was scenario, money transfer scenario. And we're actually getting to the payload encryption. So when you send a request on HTTP, you can actually see the actual data that is being sent. So this is where the vulnerability or the exposure comes inside. Let's go back now, and I'm going to let this application, that's the API. For now, we're done with the portal. Close payment. Alright, let's go straight to the portal now, the web service. So this is our web service, or the API that is going to send the data, send the money. Okay, so let's go straight to the first things first. Alright, I'm going to change this back to HTTP, not HTTPS. And the reason is that I want us to understand the HTTP side of it. So I'll just comment everything here. Okay, and then by default it goes to HTTP. So you said now it's listing on 8080. That's HTTP. And we are going to send the request to the HTTP. The HTTP URL. So this is on HTTP. We are going to analyze it with WireShark because we are still on the network. And on the network, we are trying to understand how data can be exposed. So it's still running, and this is going to be captured from the network. So I'm sending a request now. Good. So relax. Let's just relax. Let's filter. Let's search by HTTP. So let's just type HTTP. So now we are seeing a difference now. Realize that because it's on HTTP, when we are doing our post, you're on a public Wi-Fi. Let's go back to this now. You're on a public Wi-Fi and you are sending money, and then your API has no payload encryption. It's on HTTP. If I click on this, remember these are the packets that are being sent from the OSI module. I do see, and I click on hypertext transfer protocol, I see the URL that's taking the money, and I can actually see the request. That's the JSON object that is actually doing that work. Everything shows here, everything, and it's a JSON object. If you don't believe, you can actually it's showing everything to you. When you click down, it gives you the whole JSON, how it's looking like, the status, everything. It tells you everything from the JSON perspective. So this is the posting side, and this is the success. So posting, and then 200 as success. So a criminal who has ideas in, or who knows networking, will know that this is the API, the URL. He picks the URL. That's the URL here. Now I'm a thief, so I've picked this URL. Let's say I've copied it. I know this because I'm IT inclined, and I come to Postman and I create a collection, and I'll call this one I'll call this hacking intent or criminal intent. And I understand computers. I know that I'm seeing posts, so I know what I'm doing. I know that when I come to the client, I'm adding a request here. I know what I'm doing. So I'm saying send money or money I'll name this endpoint money transfer hack. I'll put it there. So this is it, and I just left my JSON body. I know that it's JSON because it's telling me that it's JSON. It's saying that it's JSON. It's showing me that it's JSON. And these are the values. I know that receive mobile number, it will be the key, and this is the value. I know because I'm IT inclined. It even tells me the string, it tells me the key, and it tells me the value. You understand? So the IT inclined person knows it. And I'm on a public Wi-Fi. You've gone to the cafe and you're using this service. There's no payload encryption as a developer. Then I start doing my ingenuities. So how many members? 1 2 3 4. 1 2 3 4. Now I just go and copy what I have to copy. So receive mobile number, copy the value or the field name, and then I enter. Now I know this, I'll copy this one too. I know that amount. Mostly don't type, just enter what you need to enter by copying and paste, because if you type, those who know that it's going to be a different outcome. It could be a different, the contract between you and the API is not defined by that the character you send. It's be defined by what they have presented to you. So that's the reason. Now I have access to this. There's no payload encryption, you understand? We'll go into it. So there's no security here, so there's no payload encryption. And I know my receiver. I have two numbers. So this is my first number. Then my second number. So the receiver mobile number will be my first number, and then the sender mobile number could be anybody's number. 027. and I enter the amount, and I enter the reference for theft, not for theft, sorry, for education. Alright, so you see that because I have access to this API and it's not HTTPS, I can see the data that is being sent. With this information, I can actually go ahead and tamper with data. In other words, if this API was provided by a financial institution or by a fintech company, they are just literally exposing or giving people, hackers, access to be able to send money from people's devices to any other devices. This one, you have to have a criminal intent to do this. You have to have sufficient knowledge to do this, because if you are not technically inclined, you can't really understand what's going on here. But because I'm technically inclined, that's why I'm going to explain why we are doing payload encryption. So if I just fire this, and then I know it's a post because this is the post, this is what the browser is seeing. So I'll change it to post. If I send get, okay, fine, it's good because the API understands both get and post, but mostly it's a post you send. You can actually change the contract. So you have been able to send money. I've had access to the API because I understand computers. So I'm on a public Wi-Fi. There is no HTTPS. It's on HTTP. Everything has been exposed for me. I can see everything that is happening, and I can just be sending money just like that, provided that this device has no implementation of OTP. That's before you send money, confirm that you are the one sending the money. So that's why sometimes you enter your PIN. A push will come to your phone that enter your PIN. If you don't like the PIN, sometimes OTP, to verify that you are the one sending the money. So this is where the understanding is coming from. So it could be any API at all. So if you have another, I'm not saying go ahead and start. No, I'm giving you the reason to do payload encryption, why payload encryption is necessary. We'll get there. We'll get there. So this is just on HTTP. Now let's go and configure to HTTPS and see the difference. So MoneyTransfer hack, this name is HTTP. Now we're going to duplicate this and make it on HTTPS, and we'll see the difference. And that will be it for understanding the two forms of communication, HTTP and HTTPS. Then we'll go into the payload encryption. So we're done with this right now here. Of course, I didn't save the request. Look at it's now just copying. Let's duplicate this again. So we are going to send our request now. So I'll file the request. And let's go to our network too. Let's go back. Let's search HTTP again. And let's look for the latest. So the latest is from the across transfer. So you realize that because there is no certificate here or HTTPS, I'm seeing the API that is sending that's actually doing the money transfer. Alright, so that's this portion of it. So now let's add payload encryption, and let's use payload encryption to see how we can handle this kind of exposure. Before that, let's put it on HTTPS. So let's go back, let me revert back to HTTPS and do my configuration. So I'm going to remove all this and make it HTTPS again, so we understand what we're actually doing before we add the payload encryption. So you realize that with HTTPS we have a certificate that is going to do encryption for us, certificate exchange between two computers, so that we know that there's security, there has been security. So that's the whole certificate thing. There's a video that I'm going to use to explain certificates, but it still follows the RSA. Certificates are mostly RSA. That's one certificate. There's a public key that signs, and there's a private key that decrypts, and two parties have to, the communication between the two parties will have to be understood. So the certificate is what's going to help you to do that. It contains those public and private keys that do the signing and unsigning. So let's put that in your mind. We'll explain all that in another CodeFilm. So now if I go back and I fire my request to the API on HTTPS, let's start filtering by HTTPS. We have no HTTPS yet. Now let's revert to the HTTPS model. Let me just pick the endpoint. We just change the schema. That's the scheme type HTTPS, and the port is 443. Let's go and confirm from here. So HTTPS 443. You have to configure it too. This is, it doesn't just appear. You have to do the configuration for everything. So if you can't configure it, meaning that you are exposing everything to the World Wide World, and that's those who are technically inclined. They understand what will be happening. Raw. So now let's have our network analyzer ready. And even describe, you're not technically inclined, but you're somebody who asks a lot of what, why, and how. You can actually break into systems. So HTTPS is gone. Now let's start filtering by HTTPS. Let's go back to the main section and let's fire again. Good. So we realize that we captured something because HTTPS is mostly SSL, secure socket layer, and TLS. Yeah. I don't really remember the TLS, but secure socket layer. I'll explain all this in another video, certificate and keys. So watch out for that video. So you realize that in this one, okay, transport layer security is showing here, but I'll explain everything, the technical bit of it. So you realize that in this bit now, you don't see any sensitive data. Everything has been encrypted. So the application data, this encrypted application data. You see, that's beautiful. So we are using a self-signed certificate to do this, but this is not the best because this is just for fronting sake. It's just client sake. There's no application security on the code. So you're just installing a certificate, so it's not really end-to-end encrypted, even though it is your SSL and TLS has handled that. It's not fully encrypted because when you switch to HTTP, you realize that you can actually tamper with the data on HTTP. You saw it. You could send money to a different number in HTTP. So now we're now going to the payload encryption. So we'll revert back to HTTP. But I know all this is not going to be shown to you when you're using MasterCard and portals that send money. You are just sending money, you know, so you are safe. But those who are technically inclined know that it's not as simple as that. A lot of things are going through, but people don't see it. So when you hear that fraud have taken place and this, you wonder how. It's not like the people didn't build systems, but you know, they are all loopholes. They are just loopholes. So some of them have HTTPS. Why should I add payload encryption? It's fine, but it's not the best because you realize that just with HTTP, you realize how you could tamper with the data and send everything. So we are good. We are fine. So if I increase the amount, it still goes. We still capture, and I have access to this API. Someone said, how would you have access? We started from the portal side, so and then we realized that we didn't have access because the developer kept the properties in the properties file. He didn't leave it in the code. He didn't leave it inside the HTML. So that's coding standard. So sometimes to aside the application security side, we also have where we do the code reviews, and it's all security using SonarQube, and it's all part of application security. So if a good developer has kept it in a properties file, a bad one would have kept it in a variable or just put it anywhere because he thinks that it should be anywhere. But you know why it was even the properties file, and why you should stick with some of the standards that people go with, constants, this and that and that. So if you use an application that actually reviews your code, you realize that if you're saying that you're not doing the right thing, you just know that you're not doing the right thing. So out of knowledge, we've seen why. But if it was experience, we have to commit the errors before. But knowledge is saving us here. Right, so now let's do the payload encryption. So the payload encryption, the format we are going to use is this. We are going to say that this is what we are actually sending. Remember, we started with plain text. all this is going inside our OSI model. It's flowing inside our from one computer to another computer. It's the same principle. So I have this data. If I want to be sure that nobody has tampered with this data, I'll call something my hash content or my encrypted content. Let me call it encrypted content. This is another member. It's a variable encrypted content. So the idea is that if I pick all this, that's the values, that the message I'm trying to send across. I'm sending this number, this, this. If I put all and this becomes a message, I build a message and I add my encryption to it. I add my encryption to it. If I compare what I'm sending and what I've encrypted, if they are the same, that means I've obeyed my encryption. But if there's a difference, let's say this is my standard encryption and someone has come to put 500, has increased it to 2400. What has been standardly encrypted and what is being sent is different. So the data shouldn't go because it's a wrong password or it's an invalid password. The original password is this, and then this. So I'm comparing what I'm originally sending to what I've defined. If there's a difference, then there's no. If there's no difference, then it's legit. But if something changes, then means something has been tampered with. That's the integrity. The data has been tampered with. That's the CIA principles. So that's how payload encryption, the understanding comes from. What if what you are sending is different from what has been encrypted, or then you know that it has been tampered with. So now we're going to we are going to actually do that. So we have our encrypted content. We are going to create a member called encrypted content. If you think you're still confusing, just make this was if this was your password and all this was your original password. Don't let the JSON confuse you. You are comparing your saved password to you are comparing your saved password to your sent password. If the saved password is equal to your sent password, then enter, show me success. But if the sent password and the saved password are not the same, then it should be error. You shouldn't get a response from my API. You get it? So that's the understanding of payload encryption. It makes sense now. So it's not like there's one way you can encrypt fully. This partial, you just pick what you are sending and you encrypt. Sometimes some people don't really trust human beings, so they'll prefer that you encrypt everything. So you can have an encrypted API where you are sending everything as text. So instead of the mem type being JSON, it's going to be text. So in this text, you are sending a fully encrypted data. So how you go about the encryption to be able to retrieve the actual POJO will be defined in someone's schema, in someone's API documentation. That for full encryption, you send me something like this or in plain text, I will understand because we have an agreement that this is what you are sending. If you send it to me, I'll be able to decrypt and pick what I have to send and do that. That's programming for you. But if you don't like this encryption method, then you can go with this one too, whereby what you're originally sending has to be compared to what has been defined. So there are two ways of doing the payload encryption: fully or partially, and that agreement has to be between you and the developer or the API documentation has been designed. So after this, you shouldn't have confusion again when it comes to payload encryption. It's straightforward. It's not difficult. Whether it's XML or it's JSON, this is just JSON. If it's XML too, the request is in XML. You should be able to do that because you know the keys, the values, and you know the encryption type, AES, symmetric or asymmetric. So we are now going to do the payload encryption for this. So let's go. There we will define encrypted content. So let's move straight to our code. Let's go to that POJO that contains that. So that will be in our schemas, mobile money request. We are going to introduce a new member. So in this class called mobile money request, we define members that talks about mobile money requests. Back in this would have been public class car. A car tells you all the members of the blueprint for the car. So these are the blueprint for the mobile money request. Right, so let's define our project. So public, so it's not public and private. By default, suppose all classes are public, all the members are public. So if let's be sure. Let's just come here. Hey, my Java, sometimes I throw my Java away. No, you don't need to even type all this. Mobile money. It's not in any method too. So it's to continue right now. Let's put it in a method, the main method. Yeah, so they are all private. They are all private. They are all private. Because I can't see them here. But if I add public to one of them, I should be able to see it here. Yeah, I see pub. So that means by default they are all private. It's all encapsulated inside. Alright, that's fine. That was just by the way. Okay, so now let's do this private already. So string, then we call it encrypted content. So this was going to hold that encrypted content. So this holds the encrypted content of the mobile money request. And let's have our getters and setters for it. So that'll just be for encrypted content. Alright, so this holds the encrypted content of the request. We are good. Okay. Now the next thing we are going to do is which encryption method are we going to use. So let's start with AES now. So I have a library that I've built. I built this library recently. It's in this package com.security.play. It has AES encryption and it has RSA encryption. So this library, I'm going to create an SDK for it and use that to do our encryption. The code, yeah, was done by Samuel or CodeFilms. Nah, don't worry. Sometimes you read, don't believe everything people say online. So let's create a new Maven project for this because I'm building an SDK file, new Maven project. The other way was to just copy the package and drop it there, but I don't want to do that. Like a folder, copy this package and I'll just drop it here. No, let's go with standards. When I build an SDK for this, you realize that you see why it's nicer to do it. So I'll call this com.codefilms and I'll call this payload. It's not only for payload, but I'll call it the payload encryption SDK. And then to be a jar, it's not short, don't worry about this. So let's just forget everything. This is the project in payload encryption SDK, or better to call it CodeFilms encryption SDK or security SDK. I'm done. Don't worry about the version and everything. So there's it for you, and I'll just copy the package here. So the artifact ID is actually the project name, and I'll paste it. I'll paste it just here. Paste. Okay, so let's see why it's crying. Oh, we need some models. What packages are these? decline the RSA. Oh, okay, let's change our build path to 1.7 or even 1.8 is okay. That's the standard Java 8 equals disappears. It's left just the AES one that is still complaining about. Let's find out what this library is actually doing. Are we actually using this anyway? If not, if it's just complaining here, not in the source code, we can actually comment it out because we don't need it. So this is my SDK. I'm going to deploy this as a jar file, and I'll include it inside my API service. So I've actually built an SDK just like that. I didn't just copy the package. There's a CodeFilms too that is coming out. That'll be on backend. Just the basics on some backend thing like files and there's a build field. Also this 5 and let's go and check all these things out. Source and target. Change this thing moving build path. If not, I have to go online, go and get some moving tags that will help us to compile in Java 8. Now let me just try again. The terminal and see. Terminal. Let's do this showing terminal. I have to try and update first. I have to update the project. Okay, it's working now. So why was it complaining? So build success. So this is our jar. So we are going to go to target. So it's inside the target. Let's refresh this. Hey, computers, everything is processed, so you have to be very patient. So it's not showing. So this is our CodeFilms jar. I'm going to copy this jar. So this is the SDK I've built. I'm going to drop it inside the mobile money services here. So I'll create a folder called lib because it's coming from outside. So let me just do this inside here. Let's actually go where it's showing on the file explorer on our operating system. So what I'm saying that I'm inside this project. This has been given to you by Maven. So I'm going to create my new folder, and I'll call this one lib or external lib, xtlib, external libraries, and I'm going to drop my jar here because I'm the one who created it. It didn't come from Maven. So in this class path, we are getting there. In this class path or in this directory location, this is for me. It's not from Maven. I can't really put it inside the Maven directory. Well, you can do that, but some do that. They go ahead like the key store like this. I created it inside here, but in the reference, I have to define the class path for it. So class path, where do I go? Key store, so that it knows that because I'm the resources. These are being read from the source main resources. So it has to know just the next directory it has to go to. So you can actually do that too, but don't complicate your life sometimes. So let's refresh this now. You should be able to see the external lib here. So this external library. So that's just the folder I've created. Now I want Maven or the ID. I want to reference this inside my project, inside Maven project. So I'll right click on this build path configure build path, add external jars, module path, add external jars. So it's not in this directory. You can also say add library. It's all up to you. So I'll just see, you can do add jars. So external, where it is external, add jars, because we are inside the project, you just come here, external library, then this. You can reference from anywhere, so you know that it's inside the same context. Apply and close, and the library will be referenced for you. Okay, fine. If you don't believe, if you click on this, you see all the classes that we created. So that's an SDK for you. But the design is different, so I'm going to that. Please, I don't know it all. So now this is what we are going to do. So we have our encrypted content. So let's start. So how are we going to encrypt this? Let's go with AES now. Let's have another main. Let's create another package and create a main there. We'll call that one com.codeFilms.moneyTransfer.security.testing. Alright, so inside this I have a Java main, so we start looking at the encryption class. Have a main, and I'll call this test, and let's call it test. It doesn't make sense, but just call it test. Okay, test app. Alright, so here inside here I can start calling my methods to do my encryption. So I'll start with the AES. So if I call AES, it's coming from com.security.play, and I'll do AES. There's going to be a new AES encryption. And then I'll just say AES dot. So okay, I can do anything now. I can do encrypt, generate keys, and all this is coming from the keys from the model, that the SDK that I built from CodeFilms. So do loop payload encryption. So you have to pass the security key and the IV parameter. I can get this encrypted security key from here. I can get the encrypted IV parameter. I can do payload encryption. So if I want to do encryption first, do AES encryption, what do I need? I need to have the message. I need to have the security key. I need to have the IV parameter. You know, AES is one secret key. The same key does both the unlocking and locking, or both the encryption and decryption. The IV parameters I said before in payload encryption fundamentals is just like padding or sorting, just to make sure that some randomization takes place in the data. We are not going to go too technically into that. So what is our message? So this is where we'll say string message. Our message is going to be our what? Mobile money request. So message will be mobile money request. Right, in other words, this is the mobile money request. That's the message we are going to build. So let's have this test here, and let's have a look at it. So this is what we are sending. We've explained the concept already. So we are going to pick all this and do that. No, because we are doing encryption, other matters because if I say a message, hi Joe, and I do this and I encrypt it, it's going to hi John. Let's do it, hi John, and I send another one, string message 2, and I type this, hi, then John, then maybe John, hi, and I say John. The two strings are not equal because the content here and the content here are not equal. If you compare the two, to tell you that it's false. So even if you compare, so let's say binary operator, boolean true, boolean success. So let me say that message 1 dot equals message 2, then ternary operator true or false. We are saying if message 1 is equal to message 2, then say that it's true. So let's see what Boolean will say. Sys out success. It's going to tell us it's false. So if message 1 is equal to message true, it has to tell us false because they are not the same. Run as Java application justice. Class not found. Why is this in class not found? Like it hasn't been able to reference our directory, our jar. Okay, let's comment this out first. We'll handle it. Don't worry. We will handle it. Don't worry. Okay, so it says false now. Alright, so that means they are not the same. So if we are going to do an encryption, let's build our message now. Don't worry about the error there. We'll look at it very soon. I think it's still known as a Java listing. We have to find a way of making it compliant to the Spring Boot. That's the issue. So we start the order. So you see that the two strings are not the same. So we're going to see that our order is going to be, we pick the receiver mobile number. Most of the time it's top down. It's the same thing, but you have to ask for the receiver mobile number plus sender. The reason is plus is you are doing concatenation. You are sending a text. If you remember from our first fundamentals, the amount plus the reference. So this is the order. So every time it's going to be the reference mobile number, sender mobile number, amount, and reference. If you change it, it will know. It will know. So you don't change it. How do you know? It's a standard. Because you have encrypted it, it will know. So this is the order: receiver mobile number, sender mobile number, amount, and reference. So let's pick the values. Let's start. Let's build. Come on. Let's have this by the side. Let's do it gradually. Sometimes when you're in a hurry, computers can't tell. So you always have to be patient. Take the sender mobile number. To receive. Okay, so this is our message. Now the next thing to do is, how are we going to encrypt it? So string, let's call it encryption. We have to find out why we're having this before. Let's do payload encryption. But everything can be solved. No worry. So first thing first is to pass the based on what was said. There's no Java doc to false. There's no documentation. It was what we were doing before. That's why we need Java doc. AES dot do payload. So message, secret key, and IB parameter. So we pass the message. How do we get the secret key? Let's look at what that says. So is there a method to get secret key? So let's see, get encrypted secret key. So that will be the secret key. So that will be the key. Key. Let's copy and paste this on top. See, there's no documentation. There's no code. Then we have string IB parameter. Okay. Yeah, what will it return? It returns a string. So string encrypted content. Let's close all this. Make this bigger. And let's out this. Let's run it again. No class found. Alright, so no class found is not coming, so it's now our fault now. So we have to solve this. Okay, well, how are we going to solve this? There are two ways. The first one is to test whether my library is actually working inside here. So what I'll do is that I'll first delete my library. No class found. There's no finding it in the class folder. I've deleted my library and I'm just going to copy the package as I explained before and test it and see. Just copy the package. The actual one is there, but you just copy and put it here and paste it anywhere. You just paste it here. Alright, then let's test this again. This time it will work because the package is inside the. Oh, where's this here come from? Oh, okay, so it doesn't exist. Hasn't it been cleared? Let's go to the build path and see. Let's remove it. Oh, why? I think it's complaining because these ones can be converted. They can be accessed by it's static inside the class, so you don't need to have a member person for it. You can actually access it directly by the class. Let me just fix that. That's the downside without documentation. Because it has to belong to the class, so you can get the actual class implementation of the keys and security parameters. That's not the main focus. Alright, so that is from our SDK. Perfect, it's working here. So meaning that the problem is coming from how we build the SDK. So let's do that again. Maybe build. Because we want to use it as an SDK just to make our recognize. Refresh this. Let's just copy it from here. Copy. Let's delete this. Because we are running it in Java main and not in the Spring Boot, it's not complaining from Spring Boot, so meaning we are not doing something right. When we create our libraries, and let's create the same file. It's complaining already. Let's create a folder. Let's call it external link. The name shouldn't have like that. Let's paste it here. Let's do the referencing again. Okay, I get it now too. Okay, that's beautiful. Let's continue. So we want to go to our build path now. It's Maven based. external jar. Apply and close. It has been referenced alright, but it seems it's not being read inside our Maven project. So let's import it again. Let's run this. Let's see something. It's good. So now let's define it in our Maven file. Going to be another dependency. But this one have its own version. Locally we have a Maven repository, so it's not finding that. So our group ID that we defined for this, let's look at our Maven profile. It's going to be CodeFilms. So how do I know all these things? They complain of no class found, so even though we added a jar, I still can't find the jar. So it has to be Maven. Okay. Why is this still complaining? Alright, sure. So with this one, you are building it as part of the project, and it's not Maven based. When you add a jar, it will pick, but if it's Maven based, it's not finding it. So let's just go back and check again. How am I sure that it's leaving the Maven repository? Like, all these are questions that important. So there's another issue, and the issue is that is the project really in the Maven repository, our local Maven repository? So I have to find out onto .m2. Every personal computer is supposed to be there's a .m2 package, so let's go and find the .m2 package first. Users .m2. So this is the .m2 repositories. The security. Let's check. Let's check the POM file here. CodeFilms. You realize that CodeFilms is not registered in our local Maven repo. So we have to do that before we can have access to the libraries. Otherwise, we can't do anything to it. When it builds, it doesn't build and go to Maven. It builds. So look at run. That's a Maven install package. Save. So that, let's use a terminal. I want to show something. Maven package. And still the same, still going to the same target directory. That's here. So it's not going to the .m2 repository, and that's the Maven configuration for this IDE. So we have to go and install the Maven jar first. So let's install it in Maven. Run as Maven install. Yeah, we'll finish very soon. So let's see. Good. So it has copied everything to Maven for us now. So that's the essence, because Maven can't find the jar. You know, if you are using Maven and even you define a library and it's not in the POM file, you can't find it. So you have to install it. So it is going to the Maven repo. So if you come here now, we are supposed to see zcom. Let's see where it went to. So installing users to, where is it going to? Maven.repository.com. So let's see com. Let's come. So this is it now. com.CodeFilms. So it's available now. Okay, so let's import. Let's see. Let's do it again. Let's refresh the Maven string. Let's clean everything. Maven update. Yeah, force update. Maven update because we want to update, you know, the POM file, every new dependencies. Yeah, so that's what we are doing. Is it done? Okay, so everything is gone now because we did a Maven update. Hey, programming. Now let's run it. Voila! So it was a Maven install. Alright, so that's good. Woo! Clap for yourselves. We are moving. Alright, so now let's continue. So now this is how we are going to do the payload encryption. So now let's go to our REST controller, transfer money controller. That's where our logic is coming in, and this is where we are going to write our implementation of encryption. Remember, it's like a password. So what we are going to say is that if the encrypted content, that's the request that is coming, the request dot get encrypted content is not equal to, so what is not equal to? It's not equal to. So you have to have a definition. So string incoming string saved password or saved or known encryption. Let's bring this down. Or known encryption, known encrypted content. We're actually doing the encryption now, the payload encryption. So payload encryption is in two ways. Either it's full or it's the partial one we discussed. So known encrypted content is going to be equal to what? Now let's use our library here. So we are going to do AES dot do payload encryption. So we will pass our encrypted key, and that one we will get it from our AES dot get encrypted security key. That's our SDK. The beauty of using it. No, that's the message. So let's pass that in there. Message here. Then our message is going to be what? The message. So our message, how is the text, the secret message here, what we did here. Let's close this, the outline. So this is the message, this is the plain text. Let's go back to the OSI model. Remember, I said everything being transmitted here is in raw text from video 1. So that's what we are building here. And then the order we are defining for that order is going to be this. We are saying that string text, call this plain text. Plain text has to be equal to, in first place, request dot get. The order is receiver mobile number plus request dot get. The next after receiver mobile number is sender mobile number plus request dot get. After, let's go look at our GSIM. You can be sure receiver mobile number, sender mobile number amount, then we get the amount, then we get the reference. So this is the plain text we built, and that's what we're going to compare it to. So our library is going to do the encryption for us, and that's AES encryption. So we pick the plain text or the message. Don't get confused now. Pick the plain text or the message. This is it. Like we are just our normal encryption we've been doing. Now we add our security key, then we add our AES.get IV parameter. And this SDK is coming from us. So we the ones sharing the SDK with you. We are the ones giving you this access. So if the request or encrypted content is not equal to the non-encrypted content, that's this, then the data has been tampered with. So payload encryption is comparing passwords. This is your known password. You have your password that you know, and you have your safe password. You are comparing your known password to what is coming. You understand? So if the encrypted content is not equal to the known password, then the data is tampered with. If it's not equal, then we just give a different mobile money response, new mobile money response. You don't even need to be a mobile money response. You can throw an exception. So what you can do is that you can throw an exception, create a new runtime exception, and then we give it a message and give it a cost. So to do that, to make that very beautiful, why don't you just create another package here, a new package. Let's create it of the branch of the com.CodeFilms, because it's coming from Maven, and we call this exceptions, and I'll call this I'll create a new class, a new object, or a blueprint to handle exceptions, and I'll call this invalid payload encryption exceptions, and then I'll make it inherit or extend runtime exception. That's the Java for you. And then here, if I want to override anything, I can do it here. And the methods I want to override, so right click, source, override or implement methods. Here's where I'll do whatever I want to do. So I can actually do my own initialization of the course, throwable, what I want to throw, anything I want to do is all up to me. I can also expose everything, so init. So to pick a throwable course, then return the course of it, or I could do a message rather. Anything I want to do, I can do it. So source, override, one thing I'll need is okay, so let's do this. So we want to find the course. So let's go with this technique. So we want to throw, what kind of exception do you want to throw? We want to throw an illegal, an invalid. It's an extending from the class. So if I don't have to do any override, so you can leave it as such first. And let's go first with what you want to do. So invalid, throw an invalid payload encryption. And first of all, pass your message and say, you can pass your message. This is what you do. Say this, just say invalid payload encryption. Now go back inside this and create a constructor for this, and then let this source let's go with this. I want to pass it to super of the implementation. That's what I want to do. So let's achieve that, but I don't have time for that. So let's pass. What's the type of this in its course? It's a throwable. So here, let me see, it has to be a throwable too. Okay, fine. Then I'll see private string message. And I'll see this dot message is equal to string. It's not giving me the I have to be able to pass it to come. Yeah, generate constructor from super class. Yeah, this is what I want. I want to pass it to the constructors over there. So fantastic. So this is what I want to pass. So not really the inits. It's a lot. So let's go back. Sources. Let's clear all this. You have to understand what you are doing. So we have a message. We have, because we are extending, we should be able to pass it to the constructors over there. So generate constructors from super class. So I want to need this will give me the normal exception. Throwable, string, throwable, and Boolean, string, throwable, string. I'll go with everything again. I'll just use what I can use. So I'll go with the message here. This is the message. So super course and course. I don't have a course for now, so I'll go with only this one. I don't want this. I don't want this, because I'll be passing a message, and I'm supposed to pass a course too. So I have to find a course for this. So super message. So how do I pass my actual message? My actual message will come from the constructor I'll create. That's when I do the constructor. So I have three constructors. This constructor, that constructor, and this constructor. So the message is what I'll be calling here. And I need another one. And then the throwable course. I'll create a throwable, and I'll call this true payload encryption. Okay. No. Why is it complaining? I think I have that constructor already. I haven't saved it. Okay, I've saved it now. So throwable. Is throwable an interface? Let's be sure. So I know what I'm passing. Okay, so throwable is a class. So I can create a new throwable rather. With a message or a course, throwable and a course. Alright. And then the message we want to throw is the encrypted content sent or has been tampered with. That's what I'm doing now. So this is what's going to happen. So I choose declarations, throw exceptions. Okay, fine, throw everything out. Alright, so this is the payload encryption. We can add some logs to make it final, but now this is what we're saying, that if what we get is not because there's no encryption, this is what we're going to true. So we have our true payload encryption, the actual throwable or what will cause it to true. We have the message, then the true payload encryption. Let's just go straight and run everything. It's already running. So we have to define that method now. If we don't add it, that object, that is not going to make our work complete. Right, so let's send the request now. Okay, let's try this. So that's good. Internal server error is not. We like internal server error. It's a good exception. Oh, class not found again. Where is this one coming from? Let's do this. Let's stop our application. Let's do our Maven update. Maven update project. Okay, let's run. Let's let this run again. Let's just fire with this request. Alright, so let's go back. Okay, that's good. We are getting somewhere. So it was because we didn't read the class. So in our classes we didn't update our Maven, so everything's working fine. So it says last unit does not have enough valid bytes. True illegal exception. Base 464 encoder. Oh, do payload decryption. Oh, sorry, I'm calling the wrong method. Do payload encryption rather. Oh, I'm so sorry. So AES dot do. Oh, I don't have access to that method. How am I doing the encryption? Oh, okay, so that one is an instant trader. Wow. My own what do you call it, SDK. I've forgotten how I wrote the logic. So AES will do. Okay, I'm sure I was supposed to have changed it. Yeah, so my bad. my bad. So every instance you can do a payload encryption. That's what it's saying. So if you have another AES1, AES2, it doesn't belong to the class, but the keys belong to the class. The security key and the IO parameters belong to the class. This is so unfortunate. That's why you should add Java doc. That's bad. Okay, so now let's work again. Let's test everything again. Alright, so let's send this and see what we get. Okay, that's good. This is good. Good. So we are getting a good response. It's saying that because here is no, it doesn't know this parameter. I haven't added any validators inside my code, payload validator. So let's just go with the encrypted content key. If you wanted to be sure, I'm answering questions I should be answering fast, so you can add at valid. chance of working. Validated rather. Okay. I won't go into that. If I'm not sure, I'll just Google. I'll Google my way out of that. I don't know why @valid is not working in this. Even I don't attempt to test that. So let's just go. Let's continue now. So let's add. Oh boy. Sometimes I want to skip things, but I realize that if I do skip things, it affects me in the long run. So @valid. Let's just do it. @valid. Spring. Maybe spring rather. Validation is another headache. So @valid is supposed to work, but I don't know why this implementation of Spring is not showing. Oh, because I haven't added the libraries. The libraries are supposed to do that. That's the Hibernate validators. So yeah, so that's just by the way. We won't go into that. So it's good we're having this request. Right. So now let's add it. Let's just go with the encrypted content here. Encrypted content. All the null pointer, all those exceptions, you have to handle it. So okay, so we have our order. So this is where we are building it. So our lab is here. So inside my code, I build it and I send it because I've given you the SDK to do that. So for every request that you do, you have to build it. Someone said it's too stressful. Well, you can go ahead and use an API to do that, but it's basic stuff. Don't complicate yourself too much. So let's run this. Let's just get our encrypted this thing. Let's pass the same thing. We are doing encryption, so we won't stick to encryption. And now let's fire the request and see what we get. First, let's fire with a change. Let's increase the amount to 2500. Make sure it's encrypted content, everything is fine. And good, it shows the exception. That's very good. So we are getting a response. You see, it's saying that the message is saying invalid payload encryption. That's the message. And then it tells you the course, it goes on, and blah 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 blah. If we don't like this message format you are seeing, then what we'll do is that we'll create another class. Instead of mobile money response, we'll change this one to a generic response. We'll call it should still return mobile money response. It can give, it should return a mobile money response, but the mobile money response should extend from an upper response, because mobile money response has status, message, and this. But if you are not okay with it because of the transaction ID, you want to return a unique response, you can do that. So you can make mobile money response extend a base up response, and that's another way. So that the only unique thing that you have is just this. So we'll create that one right now. You can also use generics too. So we are going to have schema, and we'll create a new class. Call this app response. An app response, it could be abstract, it could be so many things. Let's just go for mobile money response. Copy all this, put that inside the app response. So that means every API response will follow this. If you don't like the name, make it API response. That's it for you. And you can make it abstract, meaning that you can't extend from it. Sorry, you can't instantiate it. And let's refactor all this. Let's just refactor all this, and then source name. source is generate getters and setters. Select all. Generate. The abstract you can create generate the getters and setters. This CodeFilm has kept long over, just here. So now let's go back here. Result train an invalid payload encryption. Just like that. You can throw this, or you can. So what happens when we throw this? Or you can also define an exception handler here. There are two ways. Either we go with the app response of when this happens, this is what we do. We set this, comment this out. So how to handle exceptions in Spring Boot. So you can also have you can create a new, call this invalid payload encryption. No, sorry, app response. You make this app response. It's an abstract class, so you can extension it. Call this mobile money response. Let's just have a new mobile money response and make this the invalid payload response. Invalid payload response. And it's going to be called to a new app response. You can do this. And that's the beauty of this should work. Which one is the mother? Okay, this is the mother, so you can't instantiate it because it's abstract. Great. Let's do this right now. I'm trying polymorphism stuff here. Okay, so mobile money response extends app response. So in that case, what it means is that app response, and call this invalid payload response. Invalid payload app response is going to be called to the new mobile money. This can work. Yes, because it's the mother. This is the parent, and this is the child. If not that, I have to downcast that too. Let me set my message first. So this one, so 400, I'll say L 500 is, or 300 is payload encryption, invalid payload encryption dot set message, and the message I'm going to send is going to be the throwable payload dot get message. And then the invalid dot set status will be equal to error. And then I'll just return invalid payload encryption. Yeah, but add a cast to it because I'm downcasting to mobile money response. So yeah, so this is all we are supposed to see now. So let's go back and fire a request. Unresolved, but mobile money string. Where is the string coming from? Is there any constructor I'm not using? Console terminal. Let's go there and see the message. It's undefined. Okay. So let's go to mobile money response. Let's go back to our code and see. Maybe I've left something out. Oh yeah, I've left this out. Okay. Let's fix this. So you can still make this one abstract. If you make it abstract, you can instantiate it. Yeah. So source. Generate getters and setters. No field source. Generate create constructors using fields. Alright, so this is what we want. So super now to mobile money response is app response, and super to this is the object. So we are going to have add constructors here because we've added more than one. So it's super to that. It's public too. If you didn't want it to be public, you can make this private. You'll have an error here because you are calling super. That's the matter. But because you don't want that, you make it public. Java programmer. Now resolving this one. So you change this to string. It's more than one. Okay, so we have to add. We can add one more here. So what we do is that super will be called first. And do this dot receiver ID should be called to pass the receiver ID at the end. Where is it being passed? It's passed in the middle. So we pass it also in the middle here. We'll call this string transaction ID. And we make this equal to the transaction ID. This should work because we call super first and we call this. So you see the error is gone. Wow. We're doing stuff here. And we don't have a default constructor. So we'll come back here. We're actually down the payload encryption. All this is just Java. So for super class, let's see. We want bare metal. We want the bare metal. So let's do from fields rather. Or you can just go ahead and type it. You don't have to be lazy. Java, you can have multiple constructors. Simple as that. Random. Yeah, all the errors. Super is undefined because I'm extending so super. Right. So let's go back to super and also have a default constructor. Have one like this too. App response. And let's create a super. So most of the time it's good when you create all these things, you just create all your default constructors once and for all. Don't remove the default constructors. Always just have them there. From super class, the base one, always have the base one there so you don't have issues. Simple. Always have this before you add the vanilla this thing. Why is this package complaining? Alright, so generate from super class. So we have the top one. We have the down one already. You can also have another one too, based on what you'll be passing. You can have multiple of them. Let's save this. Okay, it has been saved. So we are fine now. Finally. Everything is working. Everything is working. Format. So let's run our application again. Let's send our request. Good. So it says that the encrypted content sent has been tampered with error. So so this is the beauty of payload encryption. So we are seeing payload encryption work because I sent an SDK to a partner to use for his work, or I've sent an SDK to be used for encryption. You haven't sent the right content, but if I do send the right content now, realize that we see success. So now if you are if I pick the API now, if I go on the network, let's go on the network. Let's go to WireShark. So this is the whole payload encryption we've been talking about. So it's now finally done with just symmetric. So the next one is just going to be RSA, and it's only the SDK that has been built. So let's listen to it again. Let's find out the request. Alright, so it's still plain text, alright. Yeah, it's still plain text as usual. But the catch now is that the encrypted content has to be passed by you. You have to be able to pass the encrypted content, but because you don't have access to the SDK, you cannot build an encrypted content. If you pass an invalid encrypted content to, you get it wrong because it has been tampered with. So this is the payload encryption. So even if you're a hacker and you pick this API, you don't know the keys to do this work, and you don't know the encryption algorithm. So that's the payload encryption they are talking about, and it's all an if statement. I'm not sure that. Don't worry about the Java that we're fixing here and there. Alright, so this is it. This is all the beauty. This is the payload encryption beauty. If block, a comparison, the text we are building, and the library SDK we are using. No one has access to this. No one has access to this. The SDK was built and shared for you to use. Alright. So now let's do it.